Hi folks, Joseph Kursky here with you to talk about an important topic. Let's teach about mathematics through the 3D scene viewer in ArcGIS Online. I'm just using a web browser, nothing to install, works on any device. My book with two wonderful colleagues called Teaching Mathematics Using Interactive Mapping from Taylor and Francis goes into this and other, in fact, 60 other lessons in much more detail. But just to give you a flavor of teaching across disciplinary lines, you can teach physical geography, surficial geology, structural geology, geomorphology, mathematics, and other disciplines with this tool. Look what you've got at your fingertips. As you can see here, I'm slicing. I'm using the measurement tools. I can measure areas, perimeters. I can teach about the relationship between those concepts through real-world data and the 3D scene viewer. Again, nothing to install, works on any device, any browser. I've got Golden, Colorado, North Table Mountain, one of my favorite landforms in the world. Great place, just outside of Denver, west of Denver. You can get a sense of the landscape. You can teach about rise over run, slope, aspect, the direction of slope. Bring it into students' real-world terms. Could you actually climb straight up the side of this mountain? Show them some ground images. Change the base map, for example, to a satellite image, as I'm doing right here, and look at the terrain. In this case, yes, you could actually climb up most of that slope with the exception possibly of that lava cap rock that's just below the rim there. You can see it gets a little bit steeper. That would be very challenging without some sort of rope. There are some places where you could get up that notch, but get that into students' hands. Have them actually use these tools to answer a series of questions. Again, you're teaching about concepts, space, place, relationships, using these powerful tools. And again, if you need some concrete examples with lessons running you through these specific activities, my colleagues and I have written them into the Teaching Mathematics with Interactive Maps book, Taylor and Francis Publishers. Let's go ahead and review these tools: measurement, perimeters, profile. If you were to actually sign into your ArcGIS Online account, which you can get through your university or through your school, you could actually do a little bit more powerful things than even this, looking at change over time, looking at shadows and how they change throughout the year. What could you do if you actually signed in? Then you could add additional layers: land use, land cover, population density, soil conditions, current weather, and much more. You could add those as additional layers to this 3D scene viewer. We're just using this without being signed in. Notice in the upper right it says sign in. In other words, no tech barriers whatsoever. All you need is a web browser and a halfway decent internet connection to be able to examine different landforms around the world. This is a global set of data. Look at landforms in your own community and do some measurements. It's always a little bit more interesting to students if you're looking at something local. In this case, I'm using this in West Denver. I teach a lot of courses and short workshops in Colorado, but it truly works anywhere. And think outside the box. Look at the Dover Cliffs. Look at Mount Everest. Look at the Exit Glacier in Alaska. Look at Hawaii and Mauna Kea, etc. Think outside the box. One of my favorite base maps or base layers is this terrain with labels. You can really get a good sense with this high-resolution digital elevation model from the U.S. Geological Survey and other sources, and really get a sense of what the landscape actually looks like in this area. Let's go ahead and dive shortly to another area. This is all of the measurements and perimeters and slices I've done here in the last few moments with you, terrain profiles, etc. And get the students thinking about, well, why does terrain profile actually matter? Well, what if you're planning a railroad or a ski lift or a power line or ... fill in the blanks. Terrain actually matters. The slope actually matters. What about in the natural world where you've got wildfires? You want to think about, can I get a crew up that side of that mountain to fight that wildfire? Do I need to do helicopter reconnaissance and some other methods? So terrain actually matters, despite books saying the death of geography, etc. Terrain actually matters. So go ahead and go to another place. Here I'm looking at Clear Creek Canyon, just up the canyon from where we were looking at before in Colorado. What if I zoomed out and looked at another wonderful feature, another one of my favorite features that's also very important to the indigenous native community in the area, and that is Shiprock, New Mexico. The old volcanic plug down there. Look at that. Oh, that's fascinating. Look at that. That's incredible. Do the same thing that you're doing on another landform and compare the differences. The height of this compared to North Table Mountain. The other aspects that we actually go into in the book is, okay, calculating the area and the perimeter, and then knowing how dense the rocks are and the weight of the rocks. How heavy is North Table Mountain? How heavy is each meter at North Table Mountain versus Shiprock versus the Grand Canyon? Different rocks have different density, and different densities, different weights. So how many Volkswagen Bugs or Beetles or Volkswagen vans, buses, how many school buses does North Table Mountain weigh? Does Shiprock, New Mexico weigh? Bring it into students' everyday experience. Wow, that's a lot. That's how many millions of cars? How many millions of bathtubs of cement does that thing weigh? So they're calculating volumes, areas, perimeters, and they're also thinking about real-world applications. Let's go to another fascinating place that's fascinating to lots of different people. It's also, just like Shiprock, New Mexico, important to the native tribes, indigenous population, calling it the Bears Formation up in northeastern Wyoming, known more popularly as Devil's Tower National Monument in Wyoming. But take a look at the landform there and measure, again, the area, the perimeter, look at it from different angles. Could you climb that? How would you climb that? What's the relationship between the height, the weight, the volume, the exposure, the slopes of landform A versus landform B? So again, students are actually analyzing and studying real features on the landscape. They're doing so in an engaged way with you posing questions as their instructor, but also allowing students to pose their own questions as well. I just love being able to do this and looking at the time the image was flown, this was the shadow. So what direction maybe was the nadir or the overhead of the satellite image? And what direction was the sun at that particular time? Maybe that was in the winter. You got this long casting shadow out to the north. I'm doing a little bit of simple measurement here. Again, you've got different units that you can use. So you can actually teach the idea of how to convert between imperial and metric, and how to convert between square meters and square kilometers and volumes, all kinds of things you can do here. I'm measuring the top of this, and you can see I've got a little spike off of there. So it depends on where you measure. You've got to be a bit careful about where you measure here. I'm going to go zooming in and taking some perimeters off of Devil's Tower. This is just absolutely wonderful. You've got 3D base maps as well, so you can do the same kind of thing if you're looking at the human-built environment, looking at Eiffel Tower versus the Empire State Building versus other human-built features on the landscapes. You're not confined to just the natural features. Now I've got a little more tight there. I've got 3,900 square meters for the perimeter, a very rough measurement there. Now I'm going to go ahead and do the same thing for North Table Mountain, and you will notice that I'm going to be able to compare North Table versus Devil's Tower. But let's do something a little bit more pertinent to maybe students' everyday experience. What's Devil's Tower perimeter compared to something like a football field? So let's change that and let's measure the football field at the Colorado School of Mines campus in Golden, Colorado. Okay, so we've got the same tools here. We can measure the area. Let's change it to area. Let's change it, and now let's do a rough estimate here. We can get further detailed if we want to, but 5,800 square meters versus 3,900. So this isn't quite as wide or as much area as a typical football field, an American football field, that is. But it's a little bit more than Devil's Tower, Wyoming. Fascinating. Well, what about that versus another mesa, or another canyon, or another valley floor, or something else that you might measure? And let's also compare the slope off of Devil's Tower versus the slope and the actual vertical relief off of North Table Mountain and Golden. Oh my gosh, the possibilities here are really endless. I'm just guiding you through a few of the inquiry-driven investigations that you can do here, and that's the key here, is that the students are actually using real-world tools that are being used out in the workplace, in engineering, in science, in planning, in hydrology, and in other fields. They are absolutely using the same tools that they will encounter in government, nonprofit, industry, and academia. So again, the 3D scene viewer from Esri, these are engaging tools being used in the real world that you can actually teach lots of different concepts across lots of different scales and across lots of different disciplines in education. And I've used these tools in primary, secondary, and university level. Now, I'm not teaching about area and perimeter so much in primary school, but I am teaching about the steepness of the slope and bringing it into vocabulary and an engaging lesson that they can understand as well. Thanks for being with me.